Looking at both of these equations, if I'm looking for a solution, what does that mean? What did we talk about yesterday that makes a solution? The answer to the set of equations, yes. What else did we describe it as? Point of intersection. And that point is what? What does it tell you about those two lines? At that point, what's true about those two lines? It's what they have in common. Okay, Ricky, I need to put the rulers on your desk. Thank you. So at that point, those lines are equal to each other, right? At that point, that's what those two lines have in common. Is that true? All right, that's what we talked about yesterday, right? Yes? Yes. All right. So looking at these two lines, if I want to figure out what the solution is, what do I do? If I'm looking for a solution, what do I do? How are we going to solve the problem? We're looking for a solution, what are we going to do? To find the coordinates, what do we do? We solve them by combining them, and so we're going to solve for x. So the first step to figuring out if there's a solution is to do what? How are we going to combine them? Set them equal to each other. Okay? So we're going to combine them by setting them equal to each other, which will allow us to solve for x. Okay? Looking at flight CG, can I automatically set those equal to each other? No? I can't? Looking at flight CG, the way that it's written, can I automatically set it equal to flight 4B? Why can't I set it equal to 4B? Because it's 2y. The y has to be by itself. That's right. Okay, so how do I get the y by itself? Divide everything by 2. Because if I divide everything by 2, that's going to get this y by itself. Is that true? All right, so let's do that first. How many of you did that first? Okay, that's good. All right, so I'm going to divide by 2 and divide by 2 and divide by 2. So I'm left with y equals 3x minus 2 and y equals 3x minus 5. Very good. So then you told me that when I want to find a solution to a set of equations, what do I do? Set the equations equal to each other. Okay, so I'm going to set those two equations equal to each other now. 3x minus 2 is equal to 3x minus 5. Okay, 3x minus 2 and 3x minus 5. What do you notice about those equations?
They both have 3x in them.
They both have 3x in them. Okay, what does that 3 tell us? That's the rate of change. It's what they have in common. Okay, so both of these equations have the same rate of change, right? They both have the same rate of change, but what's different about them?
The initial value.
The initial value, the minus 5 and the minus 2. So they have the same rate of change, but different initial values. Okay, I'm going to write that over here. Same rate of change, different initial values. Okay, that might come into play later. All right, so now I want to solve for x like Robert said. Okay, what do I do first? What can I do first? There's two different options. 3, 4. Yes, sir.
Oh, and you could add the 5 or add the 2.
Add the 5 or add the 2. Yeah. Okay, what do you want to do? Add 5, sure. All right, so I'm going to add 5, and I'm going to add 5. So what does that leave me with on the left-hand side of the equal sign? 3x plus 3. Negative 2 plus 5 is plus 3 is equal to, what's on the right-hand side? Just a 3x. So we did our job, we wanted to get rid of it, and we did. We got rid of the negative 5. Now what?
You have to get the X's on one side?
We need to get the X's on one side, because right now they're on the left-hand side of the equal sign and the right-hand side of the equal sign. So how am I going to get them moved over?
You can divide by 3.
Sure, I could divide by 3. What else could I do?
3x.
Subtract 3x. If I want to pick something up and move it to the other side, it can't exist on both sides, right?
Wait, I
So I've got to pick it up and move it over. Yes, sir?
thought since it's 3x, you multiply, you have to divide it.
If we were solving, you mean like in this case?
So like, right there, 3x plus 3 equals 3x.
Yes, but we want to move the x's to be on the same side. So I need this to be over here. I need this 3x to be on this side with this 3x.
Oh,
And the only way to move it is by subtracting the whole chunk. If I divide, then I'm just like shaving off that part.
get rid of it, okay.
Yeah, I'm only shaving off the 3, I'm not shaving off the whole thing.
Okay, so subtracting will be right there.
Yes.
And then,
So I'm gonna subtract 3x, good question, and subtract 3x. So I'm left with, what's left on this side? 3 is equal to,
With x.
so 3x's minus 3x's is 1x,
no, it's done.
it's 0. So, when is 3 ever equal to 0? Is it?
I don't think so.
Is 3 marbles ever the same thing as 0 marbles? No. So when is this ever true?
Never.
Never. It's never true. It's never true. Okay, so we put not equal to. So put a slash through your equal sign because that's not true. Okay? 3 is never equal to 0. So does this give us a solution? No?
So,
It does not? Because it's never true, so it does not give us a solution, right? Because what did you tell me a solution was? Stop, Henry.
the answer to the equation,
The answer to the equation. Is this an answer?
oh, yeah, but no.
No, it's a false answer. It doesn't work. It's not true. Okay, you said it's something that makes both equations true. Is this ever true? 3 is ever equal to 0? No, it's not true. So how many solutions do we have?
None.
None. No solutions. No solutions. That's it. So when you end up with an answer that's not true, you end up with no solutions. I want you to fill in the blank. When you're looking for a solution, silently, think about it in your head. When you're looking for a solution, it has something to do with equations. What we're going to do with the equations. What are we going to do with the equations? When you're looking for a solution, what do you do? Yes, we need to find an answer. How are we going to find the answer to a set of equations? By making them equal to each other. To find, when we are looking for a solution, we set the equations equal to each other. Does that sound familiar? Hopefully.